listen. Okay. So, very good morning to all. Welcome to all for on the third day of the GAN course. So, this is the very first lecture of third day. That is from 9 to 10 a.m. on the third day. And in this, we will take a lecture on the heat wave. Means what is the condition of heat wave on a global level across India and then finally across Madhya Pradesh, and we have a case study there. We have discussed the heat wave, the number of heat wave events, or we can say the frequency of heat wave. Then we discussed what is the heat stress, and across 7 smart cities of Madhya Pradesh that you know, like Bhopal, Indore, Satna, Jabalpur and all. So we will discuss one by one, and importantly we will discuss how to compute the heat wave. What is the important parameter or data sets you need, and after that how you can compute the heat stress. So in this we have computed 2 different indices which will indicate that how heat wave is affecting us. If that there are different classification of that heat indices, that if this heat indices is ranging from this to this value, how much discomfort will give to us. So because we know that whenever heat wave is there, it is directly affecting us. So if this much value of this particular index is available, then how much discomfort will be there for a human being or any livestock. So before going deep into the heat waves, let's discuss what is heat wave and why we need to understand the heat wave. What is the necessity of heat wave? So if we talk about the heat waves, we have lot of news regarding the heat waves across global as well as from the India. So this is the report across India itself, that some of the study warns against oppressive heat waves due to global warmings. Means we have lot of heat waves across India, and their association with human beings, human mortality in India is shared with these things. Second, if we talk about the hilly areas itself, we usually go to hilly areas in summer so that we can have less effect of heat waves. Usually, for example, right now we don't want to visit Jodhpur or Jaisalmer in Rajasthan, rather than we will go to the hilly areas, mountainous areas where we can go for some cold areas we can go. But right now, some of the study, even in 2025 itself, in March 1, they have suggested that our hills are also getting hot. One study has been carried out in Tamil Nadu hill station, and they warns about the heat waves across that part also. Mostly if we talk about heat wave in India in 2025 itself, India is going to experience above average temperature from March to May. And I think you can feel that, no need to explain this thing. Yesterday itself you can see that what is the temperature across Bhopal itself. Even I think before 5-7 days we have some rainfall. Despite of that itself, the temperature is very high, and we are feeling the temperature above than the average temperature across Bhopal itself. And even I think you can feel that even though in the March itself the temperature is very high, because we feel that mid-March is not a very high temperature condition in India, but in this March itself, in the around 15th March, we are facing high temperature conditions. So this report always shows that, and in March 1 itself, it is expected that India is going to experience above average temperature in March, April and May in 2025, and we are experiencing the same thing in March, April and May itself. Also these heat waves are also affecting the crops itself. Along with the human beings, it is also affecting the agricultural productions. So if we want to know what is heat wave and how it is affecting us, so this is the report which is given by World Meteorological Organization, and it says the heat wave can be defined as a period where local excess heat accumulates over a sequence of unusual hot days and night. So if we want to visualize the effect of heat wave, you can see that in 2022 a heat wave in China lasted over 70 days, making it the country's worst on the record. You can experience that if a heat wave persists for 2-3 days, it is affecting too much, and if it is going to be last for 70 days, you can visualize the impact of that heat wave for 70 days in that particular area. Similarly, if we talk about India itself, devastating heat waves in India and Pakistan in 2022 were made 30 times more likely due to climate change. Means what is the probability of the heat waves, but due to climate change it is increased by 30 times. So this is the effect of heat waves across India. So these are some of the information. Then let's discuss how we can detect the heat waves. What is the importance, means what is the input variable which is required to compute the heat wave, and how we can declare whether today we have heat wave or not. So there are some classification or definition which is given by India Meteorological Department. So one second, I'll share the YouTube links so that the online participants can also get that. Talk about the heat wave, there are classification given by the IMD, as well as along with the IMD there are some other classification based on the percentile. I think you know how to calculate the percentile, means you have a data sets, because percentile and percent are two different things. If I am talking about 95 percentile, please don't confuse with 95%. 95 percentile and percent is completely different thing. So there are some definition which are based on percentile. For example, if we calculate the extreme precipitation, usually we take 95 percentile or 99 percentile to calculate the extreme precipitation, based on different literature and based on different geographical condition itself. Similarly goes with the heat waves also. In the heat waves we have the classification based on the IMD, which is completely based on the temperature condition, means we have to take the average, and based on that we can go for that. For example, here itself we have shown that if the temperature, normal maximum temperature is more than 40 degree or above, then from that average, if the temperature is more than 4 or 5 degree, means the temperature is deviated 4 or 5 degree more than the average temperature of that particular area. For example, in Bhopal, if we have 41 degree average temperature and today we have 46 degree, then and this condition persists for 2 days continuously, then we declare that that particular 2 days are considered as a heat waves. That event is declared as heat wave. Similarly, if the temperature conditions are not very high for that particular area, for example some hilly areas is there, so if it is not a normal area or it's a hilly area where temperature doesn't go beyond 40 degree, then the classification that if it is less than 40 degree, for example 38 degree, then we need to increase that temperature for that particular day by 5 to 6 degree. For example, if it is 38 degree, it must be 33 or 34 degree to 43 or 44 degree to declare heat wave event for that particular area, and minimum 2 days should be required. Some of the definition says 3 days are required, some of the definition says 2 days are required. So based on the literature you can go with that. So if we talk about the heat wave events across different parts of globe, so this is a global scenario where we have discussed what is the condition of heat wave across across globe. So we found that there is increasing the frequency and intensity of heat waves across on a global level. So these heat waves are increasing more and they are more severe due to global warming and climate change, and they have high impact on human health or public health and economy. In 2022 itself, Europe experienced record-breaking heat waves causing thousands of deaths and severe economic losses due to heat waves. Similarly, if we talk about the projections or means the future forecasting of the heat waves across globe, by 2050 heat waves are expected to last longer and affect almost every region of the world. Means we cannot say that some of the regions across global are not affected by the heat waves. By 2050 almost every region of the world will be going to be affected by the heat waves. So this is the data set I have taken from the NASA. Earth Observatory, and this is shown for the June 2024 of 24 June, and you can see the temperature condition across India itself. We are not ranging below 25, we are ranging above 30 or more than 40 degree itself. So this is the heat temperature condition across India itself. If we talk about the Indian scenario itself, the same pattern or same trend is also observed in India itself. We have rising temperature, so India is witnessing the increase in the frequency of heat waves across few decades. Last 2-3 decades, we are facing the heat waves very frequently, and it is also affecting the public health. In summer 2024 itself, the country recorded more than 40,000 heat stroke cases across India. However, some of countries in the India are planning to mitigate the heat wave conditions. So cities like Ahmedabad also implemented early warning system so that they can give a warning to their residents of the states that heat waves going to be happen in particular days, so that they have implemented the early warning system. Also they have heat action plans to mitigate the impact of heat wave condition across India. So this we have taken from the Indian Meteorological Department only. Then let's go for the Madhya Pradesh itself, because the study is done for the Madhya Pradesh only. So if we talk about this is the report by the Indian Meteorological Department in 2022 itself, and they declared that heat waves between only around 40-50 days have impacted 15 Indian states and UTs across India. So you can see that out of 40 days, Madhya Pradesh is 40 or 50 days, Madhya Pradesh is facing number of heat waves during 25 days. Same case with the Rajasthan, Himachal. Even we know that some of the area are relatively cooler as compared to Rajasthan. However, there are heat wave conditions. It means we can say that the cooler or hilly areas which are relatively having less temperature conditions, also they are facing the heat wave conditions across these last 5-7 years itself. So this is the vulnerability itself. So we can say this Madhya Pradesh faces extreme summer heat, with heat waves intensifying in recent years, especially in 2022 and 23 itself. And the reason behind this is the urbanization effect, because we are creating the cities into the urban heat island effects. So that is the reason, because we are not having green infrastructure, we don't have any cooling techniques, even though we are using the number of ACs, number of vehicles to create the emissions, due to which temperature have high increase in the summer condition itself. So this is the right time that we can take the action for this, and we can do the projection of the heat wave across different parts, and accordingly we have to mitigate, or we have to develop the heat action plans for the cities or the states itself. So this is the case study across Madhya Pradesh, and this study has been carried out by my master student Himanshu Jharia in his master thesis itself. So I acknowledge him for this study. This is heat waves across smart cities of the Madhya Pradesh. So if we talk about India itself, I think I have discussed this. So this is the objective of the study. So what we done in this, initially whenever we have, I think already in last class I told that whenever you are going to take some data from any source, just try to visualize that thing. Means if you are downloading the precipitation data or temperature data set or soil moisture data set, please don't go directly for the use, because sometimes you have done some mistake during the conversion of the data set from some netcdf file to Excel file or some from other sources, and you will going to use directly. So without visualization of that particular data set, you will not able to get the problem or whatever the issue with this. For example, if you are downloading the precipitation data set and you are getting the precipitation high in Rajasthan and less in northeast or western Ghats, so maybe there is some mistake, and obviously there should be mistake in that particular thing. So initially whenever you downloaded the data, just visualize on the map itself, so that you can get average data sets. Maybe for example, if you are getting highest rainfall in northeast or western Ghat and very less in the Rajasthan, it means you can say yes, the process is maybe right, that we have downloaded the data and we have regraded the data set, or we have processed the data set in a better way. So in this we have computed the heat waves, and then finally we have assessed the heat stress and thermal indices. So in this we have used two indices to find out whether what is the heat stress across different smart cities of Madhya Pradesh. So here we have used two index. The first one is the humidity index, that consists of less number of parameters, and the second one is a universal thermal climate index, which incorporates more number of input variables, so that it will give better idea about the stress itself. So I'll tell you what is the formula for both of them and how we have done this. And here we have computed the heat waves based on the two methods. The first method is given by the IMD, that is India Meteorological Department, based on the temperature condition, and the second one is based on the percentile method itself. So this is the study area. We have taken 7 major cities or smart cities of Madhya Pradesh, that is Bhopal, Indore, Jabalpur, Gwalior, Ujjain, Sagar and Satna. And we have taken these smart cities because right now government is giving lot of fund to the smart cities. So we should have a better idea about the smart cities itself, because in the cities itself people are growing very fastly due to urbanization itself. So we have high temperature condition in the city itself rather than the rural conditions. So we must have some mitigation plan for the smart cities or the cities rather than the rural areas initially. Cities? Yeah, it is available, I think so. Yeah, I'll share with you. If you need throughout the India itself, we will share. Otherwise, if you need, yeah, I will share it. Himanshu, please share with them. So that from that link you can get the shape file of any city itself. Okay, then these are some of the data used in this study. So initially we have taken the temperature from the India Meteorological Department. However, the resolution of this data set is 1 degree by 1 degree. So it is regraded to 0.25 degree by 0.25 degree using the inverse distance weighing method that I think you know, that is IDW method. Or the simple way you can do with the bilinear interpolation also. But the problem I suggest you, because this is the most reliable data set as far as IMD is concerned, but more than that you can also go with some other data set which is going to provide the data at a resolution of 0.25 degree, because 0.25 degree is far better as compared to 1 degree. But however, since this is observed data set by the India Meteorological Department, so because of that we have to take that. Otherwise you can take the other data sets which are providing the data set at 0.25 degree, because it have high resolution. Otherwise, whatever you are doing, that 1 degree you are converting to 0.25 degree, and on a very smaller study area it can have maybe less better result as compared to the broader area. Then in this we have also downloaded the relative humidity and wind speed data set. Relative humidity you can directly take from the NCP or NCAR reanalysis data set, that is National Center for Environmental Protection, or NCAR reanalysis data set. Wind speed is taken directly from the Princeton University, and these are also available at 0.5 degree, so we have regraded to 0.25 degree. Then we need air temperature and mean radiant temperature, and all these are related whenever we are calculating the indices itself. Otherwise, for heat wave itself you need only the temperature data set. Other than that you need not to have. So let's discuss what is the methodology in this. What is the process, then how we can calculate the heat wave and thermal indices. So initially we have selected the study area, and based on that we have taken the daily maximum temperature. Means we have minimum temperature from IMD, we have maximum temperature from IMD, but for calculation of heat waves you must have Tmax, maximum temperature condition itself. Please don't take the average of that. Sometimes students takes Tmax plus Tmin by 2. So that is the average temperature. Average temperature doesn't make sense to calculate the heat wave. You have to take the maximum temperature for that. And mostly we know that we usually feel the heat waves only in the 4 months, that is from April, May, June and July. Even the literature suggests the same, that whenever you are going to calculate heat wave minimum across India itself, the condition persists of heat waves only in these 4 months, that is April, May, June and July itself. So in this heat wave identification, there are two ways to calculate the heat wave. The first one is as per the IMD criteria, in which there are two conditions. If the average of that particular area is above 40 degree, for example Rajasthan or Madhya Pradesh, the average temperature is above 40 degree, then this classification should be used, that day maximum temperature should be 5 degree or 6 degree more than the average temperature. For example, Bhopal is having average temperature of 42 degree, so heat wave will be declared only if the temperature for 2 days is 47 or more than that, like 48 or 47, 49 or more than that. And it should be minimum for minimum continuous 2 days. If today is 47, tomorrow is 47 or 48, minimum 5 degree or 6 degree or more than that. So we have to initially, for example, if we are calculating the heat wave for 7 grid points of particular area, so what you have to do, you have to find out the average average temperature of that particular area. If it comes out above the 40, then you have to use this one, that the daily Tmax should be greater than 5 or more than that, then it is heat wave. And if it is going above 7, then it is a severe heat wave condition, that is more harmful for us rather than simple heat waves. So this is the two classification for the normal areas. If relatively it is a cooler area where the temperature, average temperature never goes above 40 degree, like it is ranging from 35 to 40 itself, then the heat wave is declared then when the daily Tmax is more than 4 degree or 5 degree from the average of that. Maybe average temperature condition is 37 only, so the heat wave should be declared at 41 degree or above than that. Or if you want to declare the severe heat wave for that particular area, it should be 6 degree more or more than that, then it is a severe heat wave. So this is the two classification, because the same classification you can't use for the hilly areas or cooler areas, because it will not go beyond the 40 degree as an average temperature condition. So these are the two classification as per the IMD itself, and most of the literature will use this. Some of the literature will say that you can take 3 days as a consecutive, some of them says 2 days as a consecutive. But from the literature I found that majority of the paper are taking 2 days to declare the heat wave. So we have taken 2 days consecutive to declare the heat wave. If the second day also obeys this condition, then the second day, from second day itself we say yes, this is a heat wave condition for that. This is given by IMD only, we are not deciding. IMD have decided based on the different experiments or different IPCC reports itself. So we are blindly following that only, because this is IMD itself. But since we need to compare whether this is correct or not, so we have done the second method itself, which is based on the percentile itself. So we have taken the data sets and we have calculated the percentile. So for example, for a city itself you have 7 grid points or 5 grid points, you just take out the percentile data set, percentile of that. So I think you know how to calculate the percentile. Simply you have the data set and you can fit the data set into different distributions, that like normal distribution, gamma distribution, People, exponential, different distributions we can fit, and based on that we can find out the best distribution, and that ECDF value we can get it from that, and ECDF value will give you the percentile value of that. So we have calculated the percentile. So literature suggests some of the places using 85 percentile, some of them using 90th percentile to declare whether a heat wave is there, or 95th percentile whether a heat wave is there or not. So in this we have calculated 95, 90 and 85th, and then we have compared which one is more aligning with the IMD definition. So we found that 95th percentile results and IMD results are very close to each other, or the value are very close to each other. So we suggested that if you are going to do that, it's better you can go with the IMD and you can go with the 95th percentile to calculate the heat wave across India itself. In this we also calculated these two values, that is cumulative accidents and absolute accidents, so that we can get better idea about the heat wave condition across different part of the study area. So if we calculate cumulative it is the sum of maximum temperature condition which is exceeding our multiple days. Exceedance means from the average how much it is exceeding. So for example, if it is exceeding 3 degree, so that will be 3 degree for that particular event, then 3 degree, then 3 degree, then 2 degree, how much it is exceeding from the normal condition itself. And the maximum of all the days, for example, heat wave persists for 4 days, how much exceedance at maximum for 4 days. For example, for the very first day it is exceeding 2 degree, then 2.5, then 2 degree, and then 3 degree. So maximum is 3 degree. So this is the exact methodology for the percentile, and this is for the IMD. Then we will compare both of them. Based on that, we will calculate the heat stress. So the first variable we have used to find out the heat stress is humidity index, in which we will take the vapor pressure as the input, and the formula for this is this one. Humidity index is temperature plus 5 by 9, water vapor pressure minus 10. And second, since it is taking only very less input variables, so the second one is giving more idea about the thermal stress or heat stress across due to heat wave itself. So it is taking more variables like air temperature, mean radiant temperature, or vapor pressure. So we will calculate both, and we will look out which one is giving better idea about the heat stress. So how we can get to know that if the value of heat stress or humidity index or UTCI is ranging from one to another part, how we can define whether it is harmful for us or not. So if we talk about HD, that is humidity index, if it is ranging below 29, there is no discomfort for us. So what we are expecting during the temperature condition, the HD should be below 29, so no discomfort will be there. If it is ranging from 30 to 39, there should be some discomfort to us. If it is ranging from 40 to 45, great discomfort, so we have to avoid that thing. And if more than 45, it is very dangerous, it will cause heat stroke and possibly, or it can cause heat death. And if we talk, E is vapor pressure. So if we talk about UTCI, then this is the classification that if it is ranging from 9 to 26, then it is no thermal heat stress, so we are expecting that value for us. And if it is going from 32 to 38, it is causing strong heat stress, then very strong heat stress. And if it is going above 46, then it is causing extreme heat stress, and we need to protect ourselves from these two conditions. But since this is not in our hands, we can go for some adaptation or mitigation. We can't stop that situation, because right now itself, from the morning itself at 9, we are using the AC, so it's not possible that we can stop the heat wave condition or a temperature condition for us. So initially I have plotted the temperature data sets only. It is not very important, because we have just shown how the temperature condition is going to be persist for different different cities of Madhya Pradesh. So we have shown that, and the goal is to just visualize the trends of Tmax across different parts of the Madhya Pradesh cities. So these are the classification, these are the figures for the comparison of IMD and percentile method. You can see the first one, the first red line is showing the IMD data sets, means the classification based on the IMD definition. These are the number of heat wave days. So during that we are just looking at this. So if we see this is the IMD, then blue is 95th, then 90, and then 85th. So you can see that 85th is very far away from IMD definition. Then 90 is somewhat closer to it, and if we talk about 95th, it is more closer to it. It means 95th percentile and IMD definitions are giving similar results, so we can go along with the 95th rather than 85th or 90th percentile. Because if you take 85th or 80 or 90 percentile, it will show more number of heat wave events, which is practically, it will not look like in practical things. So better to go with the 95th percentile rather than 90 or 85th percentile itself. So I have declared here that we have focus on 95th percentile and IMD, because they are aligning more with each other itself, because they are having matching results across each others. So these are some of the results related to identification of heat wave using the IMD data set. So in this we have discussed some of these things, like Gwalior is recording number of recorded the most heat waves events, that is 68 events across this, and Jabalpur and Sagar is experiencing the longest heat waves around 11 days or 12 days. It means 12 days continuously heat wave is there, so it is very difficult that we can go outside in such difficult conditions. So mostly Jabalpur and Sagar is experiencing these things. Even if we talk about the duration itself, Sagar is recording the highest duration, followed by this Satna and Gwalior, and they have highest average duration also. Because we, for example, if a city is having experiencing 10 events, so we have taken the average duration of heat waves, and we found that Sagar is facing the highest average duration per heat wave event, with Satna and Gwalior is following the similar trends. So we can say Sagar, Satna and Gwalior are more vulnerable to the heat wave events. If we talk about severe heat wave, the most severe heat waves are also observed in Satna as compared to different other cities. Even Bhopal, Indore and Ujjain are not facing the severe heat wave condition. However, Jabalpur, Gwalior, Sagar and Satna, they are facing the extreme severe heat waves condition also. And I told you earlier also what is severe and normal heat wave conditions. These are the results related to heat wave according to 95th percentile, and these are also showing the similar results, that Gwalior or like Satna, Jabalpur, they are facing the same issue, and Gwalior had the highest average duration of heat wave across different one followed by the Satna and Indore, and these are having the highest average is 3.75 days. So in the next coming few slides we will discuss the heat thermal stresses or heat stresses across different things. So you just remember these things, whatever the value we will discuss, based on that we need to know what is the degree of discomfort. So we will discuss the value of different thermal indices. So these results are plotted only for a reason, that if we average these results, the value are ranging in between these. So you will say, sir, these are the value which we are you are showing in the plot is not having high thermal stress. So what is the effect of heat wave in Madhya Pradesh? So we have not taken the average only. This is the average. So you can see it is not going above 40. So thermal stress, high thermal stress, or we can say high discomfort will not be there if we taking the average of that. But during the heat wave event, some you can see it is going above 40 in all the cities of Madhya Pradesh. It means we have high discomfort condition. So I have just shown, I will show through these results. You can see that here we have shown all the degree of discomfort, like whatever we have classification for humidity index, some discomfort, no discomfort, great discomfort and dangerous conditions. So we have shown here for the Bhopal only from 1980 to 2024, and we see the combined effect of temperature and humidity on human discomfort. So you can see from the figure itself, and you can have the classification here. So what we know that if we look at the figure itself, dangerous heat stroke possible days have increased from 120, which is in 1980 to 1990, to 180 in the last decade itself. So this is the most dangerous heat stress for us, and it is rising from 1980 to 2013 itself. These are not changing too much, but these dangerous conditions are increasing decade by decade itself. So this is the result for this. And if we talk about the no discomfort condition, it means the last some of the discomfort, it is dropping. This one is decreasing, but this one, which is most dangerous for us, it is increasing decade by decade itself. Then we are plotting about the UTCI, and UTCI also shows similar result, that it is this UTCI, I already told that it will include the temperature, humidity, wind and radiation effects on the human body, because it have more number of parameters as compared to humidity index. So in this graph we see that heat stress in Bhopal has intensified over the time, with no thermal stress days decreasing and moderate heat stress reaching its peak from 2013 to 2024 itself. You can see the moderate one, that is this one. You can see this is continuously increasing from 1980 to this one. And if we talk about the no thermal stress, it means the no thermal stress is not changing. It is not even decreasing itself, what we are expecting, because due to temperature condition we can't expect that this will decrease, but we are trying to hope that it should decrease. But this moderate heat stress condition are increasing day by day or on a decadal basis itself. So this is a very alarming situation for us, that the heat stress across all the cities of the Madhya Pradesh is continuously increasing on a decadal basis rather than decreasing pattern. So these are some of the conclusions regarding this. If in a very layman terms I will say, the discomfort is majorly observed in this time period across different cities of Madhya Pradesh, that is 12 to 3 p.m. and I think you can feel that. And if we talk about, this is the highest one, if we go for the strong heat stress itself, it is ranging from 9 a.m. to 6 p.m. and I think we can feel right now that after 9 we need some cooling apparatus. Either we need to on the AC or a cooler. Without that we can't stay in normal fan or normal condition after 9. So this is the time where we need to have cooling condition, and for all the cities of Madhya Pradesh we are getting the heat stress from 9 a.m. to 6 p.m. and the most dangerous condition is occurring across these 3 hours, that is 12 to 3 p.m. itself. And we have also calculated the timing also, that how discomfort will be ranging from different period itself. So mostly some discomfort is there, great discomfort, then strong heat stress and very strong heat stress itself. And mostly these more thermal stress are observed during the heat waves rather than non-heat wave conditions, and heat stress intensity significantly increasing during the heat waves rather than non-heat wave events. So if we conclude about this study, so heat stress is highest at the midday, that is 12 p.m. due to direct solar radiation and peak temperature condition. And if we talk about the humidity also play a big role whenever we talk about the heat wave condition itself. You can also think about some of the cities which have high humidity like Chennai itself. So due to humidity reduces the body ability to cool down through sweating itself, due to which it increases the temperature and risk of heat related illness. So high humidity shows a greater probability of heat stress, because if humidity is less, our body will cool down very quickly due to sweating process, but due to humidity itself our body will not able to cool down due to sweating, due to which the temperature condition or heat stress condition arises more. Next, we can conclude that during the non-heat wave periods there is still significant risk of heat stress due to persistently high temperature condition, because we will not say that only during the heat wave conditions there is a heat stress above, because for example right now we are not facing the heat wave, but we are facing the high temperature condition, so it is also causing heat stress to us. So both periods we have to mention, whether heat wave or not non-heat wave period also, both are important during the high temperature condition. And the major reasons to cause heat wave across Indian cities is due to urban heat island effect. Because in cities we have high population density, concrete infrastructure and limited green spaces in the country or in the cities itself, due to which it traps high heat for the extended periods, which creates high temperature condition across Indian cities or cities itself. And this heat stress intensity and discomfort level vary significantly across city due to temperature, humidity and local climatic factors. Means these heat waves depends upon various factors, not only the temperature, also about the humidity across that part, and along with that local climatic factors which are also playing the crucial role to define the heat wave. So these are some of the conclusions which can be helpful for the policymakers to develop the effective prevention mitigation measures against the heat waves across Madhya Pradesh. These are some physical processes that drives the heat waves, so that we can get a better idea about the heat waves rather than taking only temperature as an input variable. Second, some of AI and ML techniques can also be used so that they give better results regarding this, and they can help in the better projection of heat wave across your study area. And based on that, we can develop city specific mitigation measures, such as we can suggest green infrastructure and some cooling techniques across Indian cities or Madhya Pradesh cities. Thank you. I think we have Professor Lixin Bank here, so we will start his lecture after 2 minutes. Yes, because in this we have not taken humidity, because humidity also plays a great role in the heat wave itself. Because in absence of humidity, you can see, I think when someone has visited Chennai or Calicut, you can feel that even in the less temperature condition, we are getting more panic in the high temperature condition rather than here, because we don't have humidity feel. Like in Delhi, you have high temperature condition, high heat stress condition, but lack of humidity, it will help you out to cool down very quickly as compared to Calicut or Chennai. So that humidity should also be taken into the consideration whenever you are calculating the heat wave. For example, the same formula you are using for the Chennai or Calicut and the same formula you are using for Delhi. So it may have some disadvantage, because there humidity is playing some role. In Delhi we don't have that. Right. Right. For example, if you are taking the coastal area also, where wind speed is high, for example. So if you are not considering the wind speed also, that can also affect something, because wind speed can help you out in the high temperature condition also. So humidity, wind speed and temperature, all these means local climatic factors are important. You cannot say, so this is a universal formula you can apply any place. Some places are coastal, some are like hilly areas. So hilly area have different climatic parameters. So you can take the wind as an input parameter, you can take humidity as an input parameter, or you can take temperature along with that other local climatic factors for that particular area. Because same condition is not persist for the Goa. If you compare the Bhopal with the Goa, or like Visakhapatnam, you can say. So that is having different climatic parameters across Visakhapatnam as compared to Bhopal. So you have to make the changes accordingly. But since these 7 cities are very near to them, so need not to make much more changes. But if you are taking different parts of the country or different parts across the globe, you have to consider this.
Is there any elevation-wise variation among these 7 cities?
A deviation?
Elevation-wise variations.
Variations in the definition?
No, you have mentioned that 7 cities of the Is there any elevation-wise variations?
That we can consider. Means more number of input parameters we will take, obviously the accuracy will increase. For example, if we talk about any of the extreme event, for example flood or drought, you are taking precipitation as an input variable, you can say this is a meteorological drought. If you include SPEI for the meteorological drought, it will include more parameters, so it will give more accurate definition. Similarly, if you include the third or fourth parameter, I think it will give better result as compared to SPI. So more number of input parameter, obviously it will help you. Anyone else? Sorry, sir. You can.
So for the first lecture, I'm going to discuss agriculture and drought. So basically, how drought impacts agriculture and what kind of mitigation strategies we can do to minimize the impact. So this section, I'm talking about mainly use meta-analysis. Remember, we have a tutorial later on that will be rely on this same technique, so you can have a feel what it is, why people are using that. So majority of the work I'm going to talk about here is done by a former postdoc in my group, Dr. Stephanie Darianto. So when we think about agriculture, right, so we have actually a very small amount of plants we use for agriculture. Right? So we know on Earth we have almost like 200,000 flower species, many different type of plants. But when you think about agriculture, we only use a very small proportion, like 0.1% of the plants actually plant species are used for agriculture. You know, it's very actually small amount. So out of that, actually only 17 species that already account for like 90% of the food supply, right? So if you think about, you know, like one of the major staple we eat are cereal crops. Actually, the top 4 cereal crops, they already account for 70% of the food supply we actually eat every day. Anybody can guess what are the top four like cereal species we eat? Rice, yes. Wheat, yes. Millet, you mean? No, millet actually not one of the top 4. So one of them is actually heavily grown in the United States. In other places, you didn't mention corn, maize, right? So that's actually pretty large. And then the 4th one is actually barley. So that's actually the top 4 major cereal species. It's just amazing these 4 species already account for like 70% of our food supply. So just give you the idea, you know, how kind of diverse, right? It's not, the food we eat is really not diverse, right? So that's a part of the reason a lot of time we don't have a very robust response to environmental like a drought or flooding condition. So when we think about the relationship between climate and agriculture, so on the one hand, you know, the climate condition will impact the agriculture yield, right? We have heat waves, drought conditions. Same time we could have flooding, right? So they both impact agriculture production. So at the same time, right? So when we think about agriculture, it's also a big player in terms of regulating the climate, right? We talked about yesterday, agriculture is the largest N2O producer, right? So that is a very powerful greenhouse gas. At the same time, agriculture actually does produce other environmental consequences, right? One of them, for example, you know, for phosphorus and nitrate, so we use a lot of fertilizer in agriculture, and we tend to use a lot more than crop needs. So then leftovers, they will get into the water bodies, will actually causing the environmental issues, right? So I guess the point is agriculture and environment, they are two-way interactions, right? So environment, the agriculture impact environment also impact agriculture. So we have to think about these two-way interactions. So in terms of a drought, right? So we all know drought is very common meteorology phenomenon, right? It's happen any climate condition, right? So it's very hard to predict. Usually drought happens slowly and then cascaded into a big events, right? So, but that's typically how drought works. But remember, you know, we have a newer type of a concept called a flash drought. I think Vikas will talk about that, right? So it's a very fast involvement of drought. But typically drought happen very slow pace. So, you know, there are indications showing that under future warming conditions, the drought frequency and the intensity will likely increase. And also by our work, I will talk about this for next lecture. So we'll basically show you even without increase of a drought condition, the vegetation growth already become more and more water limited across the whole northern hemisphere, right? So that's tell us, you know, we have to think about water stress, have to think about drought impact. So for this talk particularly, I'm just trying to answer two simple questions. One is how drought impact different food groups, and also how different management practice we can do to minimize the drought impact. When I talk about different crop group, I'm really referring to the FAO classifications, right? So when you think about the FAO, they classify our food into three major groups. The biggest one is the cereal, right? So the one we talk. And the second largest one is the legume group, you know, like soybean, for example. So the third one would be anything grow underground, like a tuber or, you know, potatoes, sweet potatoes, things like that. So again, you know, the method I'm going to use to talk about this is called meta-analysis. So meta-analysis, in a simple word, is a statistical technique, right? So you actually don't collect data yourself from the field. You collect data from literature. So people already publish the work. You collect, you digitize the data, and then you redo the analysis for hundreds of papers. So the advantage for that, you can imagine, you can have a very quantitative way to synthesize all the published research, and you can hopefully like reconcile some of the difference. You know, this study found this impact, this study found the other impact. You can think about why that is happening, right? So there are a lot of advantage for meta-analysis. We're going to talk about in more details in our tutorial, but just give you an idea. That's the method we are using. So I'm going to just talk about the three groups one by one. So the first group is a legume group. So, you know, that's why with like all the beans, basically they belong to legume group. You know, right now, basically in the western part of the world, people promote the legume as a healthy food choice, right? So because they have a high protein, and yeah, they just encourage people eat more of them. And for legume, there are two types. One is pulses, one is non-pulses. So, but we don't need to worry about that right now. So really, we try to look at figure like this. That will be the major figure. I'm going to show several of these. So the x-axis in this one is basically the yield reduction in responding to drought. And each bar here represents one species, one crop species, like gram, right, chickpea, like soybean, groundnut, like basically peanut butter, like peanut. So, and then for each bar, for each bar, you have that is the mean value, and then the horizontal bar represents the 95 percentile, 95 confidence interval. So basically, what tell you if two species, if the bar are overlapping with each other, that means their response are not different from each other. If they are far apart, not overlapping, that means their response is different from each other. So that's basically all the figures will look like. So what we saw here is for legume group, you can see actually it's very widespread, right? Some species are very sensitive to water reduction, to drought condition, like a black gram, right, is up to almost 90% of yield reduction. Some other species like a soybean, right, groundnuts, they're like a 25%, right? So it's actually much less reduction, right? So that's the first message we can get. It's just a huge spread of that. And also there's a huge difference between different species. And then we can think about why that could be the reason, right? For legume, because most of them are the natural fixers, right? So they fix nitrogen from atmosphere, right? Working with the bacteria. So there are two types of this natural fixer relationship. One is called interminate, one is called determinate. So the major difference is really the relationship between roots and the root nodule. How do they actually associate with each other? So for the determinate, so the major feature for this is the root nodule actually grow outside the roots. So that means if plants are under water stress, so the root nodule can detach themselves and just detach from the roots. So we think because of this, that's why for species like green gram, black gram, for this type of species, for determinate, so they are the group actually are very sensitive to drought condition, right? So that's our thinking for this sensitivity. But for soybean, remember this one also belong to this group, but soybean is actually not that bad. Actually, the reduction is much less, right? So that's part of the reason we think for soybean, for example, wheat, for other like major species people eat every day, people have already been through so many generations of a genetic like breeding, modification, a lot of things actually try to improve their drought resistance. So then what we look next is a phenology stage. Basically, what's the drought timing, right? So drought could happen, for example, in early stage of a plant growth, but could happen in late stage of a plant growth, right? So the message here is, you can say for early stage, the yield reduction is quite small, but for late stage, for reproduction stage, the yield reduction is much higher, right? So that's not something surprising, right? Most of farmers probably know, right? So if the drought condition happen in the flowering or even later stage, that's very bad for plants, right? So you have to take actions for that. And then we also look at the soil texture impact, right? So because we know some soil are sandier, some soil are clayish, and we want to look at how the soil texture affect the yield response. So what we found here is for coarser soil, actually, and even fine soil, their reduction is actually not that bad. But for medium soil texture, that reduction is much bigger. So that's is kind of counterintuitive, right? Because we know medium soil texture is actually good for plants to grow. But here, what we show is even it's good for plant growth, but if you have a drought condition, it's actually very bad for plant growth. So that is the legume group, and then the next group, this is the biggest group for our food production. That is the cereal, right? So like I mentioned, like corn, like wheat, and they all like belong to the cereal group. So different from legume. Legume has many different families getting together. For cereal group, all of them come from one family. Is very few families, all like a grass, right? So that's why they are for grass. For their inherent nature is a grass family. They have a much deeper roots, right? So that means they're already like a drought resistant compared to many other different species. And so that's what we saw here, right? So in general, you can say first thing is for cereal, right? So their spread is much smaller, right? It's a very narrow range, except anaerobic rice. That's why it's all over the place. But for others, you can say it's actually much narrower range. So, and also the rate of production is much smaller, right? So it's like a 35%-ish. So that is another key message for this. So for cereal, because we have so much data in the literature, besides the yield reduction, we can also look at their drought sensitivity. So what I mean drought sensitivity is the x-axis is basically the degree of water reduction. The y-axis is the yield reduction, right? So I can do that for all the species. I can take the slope of each species, and then I can put them together. So that's give you how sensitive for each species are responding to drought. So there are differences in drought sensitivity, but what I highlight here is the difference between wheat species and maize and corn, right? You can see here, maize is actually much more sensitive compared to wheat, much more sensitive to drought, right? So that's in a way is also counterintuitive, because we know maize, they are C4 plants. They are using water very efficiently. Water use efficiency is quite high for maize. But then what we saw here is, but they are very sensitive to drought condition. Even they are very high, even they have a very high water use efficiency. right? So basically what they tell us is water use efficiency and the drought resistance or drought tolerance is not the same thing, right? Even some crops, they are water use efficient, they could be very sensitive to drought condition, right? So that kind of thing is counterintuitive, but sometimes it's only emerge if you actually use a very large amount of data set to be able to do that. And the last group we look at is called the tuber. Tuber essentially refer to all the species grow underground, right? Like sweet potato, or cassava, like here, right? So the idea is, some cultures, they actually rely on a lot of the food on the tuber group, right? In some country in Africa, right? So they actually rely on cassava quite a bit. So for them, what we can see here is they are quite sensitive to water, right? So the reduction is 60%-ish, quite high. But also, one interesting thing is for tuber species, we were able to look at the drought sensitivity for both tomato and sweet potato. These are the drought sensitivity when we put them together. So basically what we saw here is for sweet potato, the drought sensitivity is actually much bigger than potato. So, again, when you talk with farmers, it could be counterintuitive. People always think sweet potato are hardy plants, right? When you grow them, people tend to think sweet potato are much more drought resistant. So, but here what we saw, what our results actually tell us is sweet potato probably is a hardy plants in terms of survival. They don't die if you have a drought condition, but doesn't mean they will produce food, right? So basically it means their survival is pretty strong, but they don't really have a high yield potential if you have a drought condition, right? So that is a kind of a key message for this comparison. So I guess overall, really, when we put all three major groups together, right? So really, the message is, there are very big variation in terms of different group, different species respond to drought condition. Some species are very sensitive, some are okay, right? So some are in between, right? Also, like I mentioned, one of the major difference between these groups, some reason is a kind of a inherent nature of the plants. For example, cereal species are grasses. They tend to be drought resistant in the first place, but also because they have deeper roots. But also, for a lot of the cereal species like maize, wheat, and also some legume species like soybean, right? So they have a lot of genetic modification has been done to them, so they are becoming less sensitive to drought, right? So that's both play a role. To summarize this part, basically what the ones already talked about, really we talk about like cereals. They are the most robust among all three groups in terms of drought resistance. So that's related to their inherent property, but also related to how many research, how many studies has been done for this group. And we talk about in terms of drought timing, right? So in terms of the soil texture. So if you have a medium soil texture, so that is good for plant growth in general, but that doesn't mean help with the drought, right? So if you have a drought condition, medium soil texture tend to have a highest yield reduction. And also drought timing matters, right? So if you have a drought happen in the early stage, in vegetative stage, maybe that's okay. But if you have a drought happen in the later stage, you have to take action quickly to avoid the big loss. And also by comparing maize and wheat, so basically what we show here, water use efficiency doesn't mean drought resistance. They actually are different things. We can't really use them interchangeably. And also by comparing sweet potato and potato. So basically what we show here is for drought resistant plants, sometimes people call them like a sweet potato. Doesn't mean, usually they mean that's their survival capacity. They don't die, but doesn't mean they can still produce yield very well. So what we should do, right, to keep improving the drought tolerance or resistance. So one thing, of course, we can continue doing the plant breeding, right? So we can already saw the impact for cereal and some of the legume species is very effective. But also there are some agricultural practice you can do, right? So I will talk about a couple of them, give you example. Like one is mulching, one is no-till. So mulching is a practice people use quite a bit in dryland agriculture. Right? So it was first started in the United States for mulching technique, but is right now the technique is more widely used in China, in western part of China. So basically you have a plastic cover the soil surface, and then you make ridges and valleys, right? So you make a hole and you plant crop here, typically like maize or corn, right? So what happens is when you have rainfall events, the water actually will run down to the hole, will get into the hole, right? So plant can use, and then the cover actually reduce evaporation, right? So that is a very effective water saving technology. So we did a meta-analysis, try to look at how effective this practice compared to irrigation. So we look at, you don't need to, there are different types of mulch, right? You can use plastic, you can use like a straw, we don't need to worry. Let's just look at the top two. So that is the irrigated treatment, and then you have plastic mulching. And we look at soil moisture change, yield change, water use efficiency change, and also ET. So really the key message you can see here is, if you compare the soil moisture between mulching treatment and the irrigation treatment, they are almost the same, right? So, and also when you look at the yield, they're almost the same as well, right? So basically, without any irrigation, the plastic mulching can produce the same yield as the irrigated crops. And then when you look at the ET part, you can see actually irrigated part has a very big ET loss, and the plastic mulching part has a very small one. So as a result, that's why water use efficiency is much higher for plastic mulching, right? So because water use efficiency, you use yield divided by ET, right? So, that's basically tell us, from the water perspective, the mulching treatment is very effective. It actually can produce the same amount of crop yield without using much water at all, right? Without any irrigation in this case. But the problem for plastic mulching, of course, is an environmental concern, right? So because you tend to left a lot of the plastic in the field, that's actually in the long term is not necessarily a good thing. So the second practice I'm going to discuss is called no-till, no tillage. So it's been promoted as a conservation practice. So essentially, you don't really plow the soil after harvesting. You just left all the residue on the ground, and this is a traditional tillage. And this one, because you have the crop residue cover on the ground, that's reduce evaporation, right? So reduce water loss. So that will be very helpful for plant in terms of the water use. So, but the problem for no-till, for example, one of the things people found is no-till actually can induce increase in N2O emission, right? So because if you have a very good soil moisture condition, and also you have a lot of residue on the soil surface, right? You have has a lot of nitrogen there, right? So you introduce a lot of the N2O emission. But we don't know. But what we don't know is really how no-till will change the water quality, like the nitrate leaching and other nutrient leaching. So in literature, the results is kind of mixed. Some found no impact, some found reduction, some found increase, right? So that's why we want to look at this through a meta-analysis point of view, try to look at what the consensus is, what the overall conclusion for this. So before I talk about the results using meta-analysis, I will talk about how no-till actually change soil property and how that related to the nutrient leaching, right? So first off, if you have a no-till, means you have a plant residue on the soil cover, right? So that means you tend to physically block the water flow, right? So that means you reduce the surface runoff, right? But at the same time, if you do no-till for a very long time, soil will be compacted. So that means water not easy to infiltrate inside the soil, right? So the soil compaction actually will introduce to like a increase runoff. So no-till could either reduce runoff or increase runoff, depends on how long the practice is, depends on particular situation. So that's one impact on no-till on nutrients. Another is because you have a soil organic matter, right, on the soil surface. So basically that means you add a lot of potential nutrients. So that means the concentration from the runoff very likely will increase. And also the leaching is vertical. The concentration of both runoff and the leaching likely increase just because you have a lot of the organic matter on the surface. And also no-till tend to create a lot of the micropores in soil. So the micropores can make the water flow much easier, right? So that means the leaching, the volume of water from no-till could be bigger. So then when you think about the environmental consequence of a no-till, you have to consider all of them, and then what is the net impact of a no-till, right? Then we can take a look for the nutrient impact separately. First, we look at the nitrate, and then we look at the phosphorus. So for each nutrient species, I'm looking at both concentration and also load. Load is basically the product of a concentration and the volume, right? So because that is really the total amount of nutrients coming out of agricultural field. So this is more meaningful. But we still use concentration because some farmers or some research, they only report concentration. That's the only information you have. So we still use them. So again, that's the same kind of layout. So the x-axis basically tell you the changes in concentration. And so if you have we have a zero line here, right? So if you have this 95 confidence interval, if this one overlap with the zero line, that means statistically there's no treatment effect, there's no change like this. But if this one is on the right side, that means your concentration is increasing, right? If on the left side, means concentration is decreasing, right? So basically what we saw here is interval concentration. No-till does increase the surface concentration for nitrate, right? So this makes sense. Like I mentioned, if you have a crop residue on the soil cover, right? So they actually will add organic nitrogen, and they will mineralize, become nitrate, right? So the concentration is increasing. But for leaching, we didn't actually say the concentration is the same between no-till and the conventional tillage. And then when we look at the load, right? So that's different. You can say load is actually there is overlapping with zero. That means for nitrate, the load is actually the same between conventional tillage and the no-till. So what that means, but we know concentration is higher, right? That means the volume, the runoff volume is actually smaller. That's why when you make the product, the total is actually not changing. So that's what tells us about the total runoff for nitrate. And then when we look at the leaching, right, the concentration didn't change much, but actually the load is actually significantly higher under no-till compared to conventional tillage. So, but the concentration didn't change. That means must be the volume directly like increasing. So then the end product means the load is increasing, right? So I guess the summary for that is sometimes you can say the difference between concentration and load results, and preferably this one is preferred because this is actually telling you the actual total amount of nutrients coming out of the agricultural field. So concentration just a part of the story, not the full story. Load is the full story, right? So because load has both concentration information and also volume information. So that's for nitrate. So the next one will be for phosphorus. So phosphorus, there are different forms of phosphorus. You could have a total phosphorus, you could have a particulate phosphorus, and also you can have a dissolved phosphorus. So we look at them separately. So, but we also look at concentration and load separately. So you can see in terms of concentration, right? So the total P and particulate phosphorus, they actually has a lower concentration under the no-till treatment, right? So that makes sense because the no-till physically really blocks the total phosphorus. But for concentration, actually we saw for dissolved phosphorus is actually much higher. So that means you have a residue, they actually adding the dissolved phosphorus. So the concentration is actually higher under no-till treatment. So that is the concentration. So for total load, that's actually almost the same as the concentration. You can see total phosphorus and the particulate phosphorus, the total load is actually much lower under no-till treatment. But for dissolved phosphorus, the load is much higher under no-till. But remember when we talk about the water issue, right? If you think about eutrophication in lakes, for example, so the most important source is actually dissolved phosphorus. So no-till increasing the load of a dissolved phosphorus means that's not good, right? So that means you potentially can introduce the eutrophication problem, right? So, but that's basically tell you, for both phosphorus and the nitrate, so no-till actually has the potential to increase the loss from agricultural field. So after this, we then take a look how kind of different climate condition and different water condition, how that will change the phosphorus or nitrogen loss through the agricultural field. So here basically what we did is we classified the agricultural field into like a dryland region and a non-dryland region. So what we saw here, you can see for both on the top is the nitrate, bottom is the phosphorus. So you can see for they almost similar, right? So for concentration, you can see dryland is actually has a much higher concentration under no-till compared to conventional till. And the load also similar, like under dryland conditions, there are much bigger load, bigger both nitrogen and phosphorus loss through agricultural field, right? So that's one thing. Basically, the geographic region impact, right? So if you have a drier region or lower or wetter region, basically we saw here is a drier region, the issue is much more severe. So, and then we can look at one region and then look at wetter period and drier period, right? So what we saw here is, if for one particular location, when you say wet year or normal year or dry year, regardless the concentration or load of phosphorus, nitrogen and phosphorus, you can see actually the drier years, they tend to be higher, especially for load, right? So basically for both dry land and also for drier years, the nutrient loss will be much bigger, right? So that's basically the results tell us. So really what that means is we know there is a potential for higher nutrient loss from the no-till field, right? So that impact is much higher under dryland or water limited environment or under dry years, right? So that the implication for that is, as we all know, if you think about the future climate predictions, a lot of time the dryland become drier, right? And also some other places they tend to have a higher frequency of drought condition. So that means the nutrient loss issue will become more severe in the future. Right? So that's basically the implication of such results. So to summarize this part, really what we talk about is, when you think about the nutrient loss from agricultural field, sometimes people use concentration, sometimes people use load, but actually you can't use them changeably. They don't always tell you the same answer, right? So, and preferably we want to use load because that is a more accurate a representation of a nutrient loss through agricultural field, because it's not only considered the concentration, it's also considered how much water get lost. Right? So based on this study, basically what we show here is for no-till practice, no-till is pretty good for reduce soil erosion for other things, but for water quality part is really has a very limited could be not even like positive, it's actually negative impact, right? We talk about dissolved phosphorus and the nitrate loss are much higher under no-till condition, right? Especially under drier conditions. So, that's basically lead to like even higher nutrient potential loss under future climate conditions, right? So that's basically prompt us to think about then what's next, right? So what additional things we can do to minimize the no-till impact, right? So one of the things we can think of is basically adding additional agricultural practice to minimize the impact. So traditionally when people doing the no-till, when they harvest the plants, they left the residue on the ground, but it's basically nothing else. So that's why a lot of time nutrients get lost to the groundwater, to the surface runoff. But if you actually, instead of keeping the ground fallow, one thing you could do is actually you're adding the cover crops during the fallow season, right? So that actually can take up the nutrients, can actually reduce the nutrient loss, right? So that would be a better way, in addition to no-till, right, to help with the environmental conditions. So that's basically kind of is a new perspective I wrote this year. So basically think about drought in agriculture and what kind of the strategies you can do to minimize the impact. So the key figure for this one is this one, right? So we discussed, there are many long-term strategies you can use. You can build in reservoirs. You can, make terraces, like make the place more water use efficient. But this one are good, but they are very costly and very like long-term oriented. But there are many things like a no-till cover crop. They are like a much smaller scale implementation is possible. It's very much cheaper. So that's kind of things we should be focused on, right? So that's what we talk about. You can modify the soil, right? So that's the kind of yellowish color, but you can also change the crop. That's a green color, but you can also change the water. Right? There are many different ways you can do, right? So they can be responsible for maybe like a seasonal drought. Some could be responsible for like mitigate the impact for flash drought. Some may be responsible for like a long-term drought. So that's kind of just a kind of a summary about the thinking. What kind of different practice you can do. How do you put them into different categories in terms of soil condition, plant condition, water condition, and how that impact the different time scale of drought. Some is long-term drought, some is short-term drought. And in the middle, we give kind of the mechanism, right? Why this drought mitigation strategy works, right? So some we know because of the change soil condition, some we know the changing plant condition, some is basically like water condition, some is combined with the soil condition and water condition, right? So hopefully you have a chance, you can read the perspective, think about that. So I guess really, just a quick summary of all today's talk, all the first part, the first lecture. So really, we are talking about, when we think about the agricultural production, they are really threatened by the climate variability, especially drought condition, right? So that is actually very significant factors. But the impact is different for different crops, different crop groups. And also we emphasize here is some of the practice people use to mitigate the drought is actually could have a kind of unintentional consequence, like no-till only no-till, right? So that one could actually impact water quality, right? So you have to think about the additional ways to minimize the impact. So that's why we talk about you have to think about the synergy from multiple practice. You integrate them, and then like no-till plus cover crop, put them together. So that's that way you can actually reduce the impact of drought on agriculture. So I think that's all for this part of lecture. Like I mentioned, the majority of the work is done by my former postdoc, Stephanie Darianto. But also I want to acknowledge all the work from earlier former groups, including Vikas. He stayed in my group for about a year. So yeah, I guess thank you guys. I'm happy to answer any questions, or if you have anything not clear, you want me to elaborate or clarify, I'm happy to do that. Thank you. So any questions, comments? So again, the analytical method we are using is a meta-analysis, right? So that's the ones I'm going to talk about in more details. You actually have a hands-on exercise yourself and do that. So that's basically you can generate things like this, right? So this one is good. Is a synthesis of hundreds of papers, give you a very quantitative information. So I guess any questions for this? I know it's probably new for most of you. You probably never done anything yourself on this, right? So if you have questions, feel free to ask. But also you can save that for the tutorial as well. Okay, I guess if no questions, we'll just take a break from now. For now, I guess wherever I was told I will continue the next, I will start the next one. We'll just take a break for now. And if you have a question, feel free to come to me to ask separately. All right, thank you guys.